button topic I've had in my past tutoring sessions here is taking limits at negative infinity. Reason being is most people get the hang of taking limits at positive infinity, and they wondered how is taking it at negative infinity different. I want to make this video to clear it up a bit. Limits at negative infinity here. So if you remember when you do your limits at infinity, the idea is you're using this property here that this is going to approach zero. The idea is if you have 1 over x to some power of n, where n is greater than or equal to 1, it has to be a positive number, then you'll be good to go when you take this limit. Also, it doesn't have to be 1, so it's going to be 0. It needs to be a positive number down here, and it'll approach 0. And so we saw in our fraction problems, when you do these limits, you do something where you multiply the top and bottom by 1 over the biggest exponent, and things simplify really well. And so the question is, how is it different when you take it at negative infinity? So let's do an example here, and I'll walk you through where it changes and where it doesn't change. The TLDR is it won't change when you do it if there's no square root involved in your problem. So for example, let's do this one here. 3x squared minus x minus 2 over 5x squared plus 4x plus 1. So you might recognize this one. I had used this one in a previous video when we had done limits at infinity. The idea with this here is the same as before. We're going to multiply by 1 over the biggest exponent that we see, in this case x squared. So we'll go through these steps here. Let's keep going through it. I'm going to multiply this out on the top pretty quickly here. So if you don't believe me, just double check your algebra. We got this over this here. Okay, now we're good to go, right? Because we can do a property now, because if I take the limits of these individually, this goes to 0. This goes to 0. It goes to 0. So it's a 0, not a 6. This goes to 0. And so our answer, we're left with just 3/5. And we saw this in the last video. All I did was put a negative here, and you're like, hey, that's the same process. And I'll say, yes, it is. The idea is this property up here is true also for negative infinity. So I can replace this with a negative infinity. So you may be wondering, when is this process different? And I have a perfect example here for you. And the summary of it is when it involves square roots. Here's a little sneak peek of why. When you take the square root of x squared, that could be positive x or negative x. To refresh your mind, the example I have is like if they gave you the equation x squared equals 16, the answer to this could be x equals 4 or x equals 6. Or sorry, not x equals 6, x equals negative 4. I don't know why I said 6 there. The idea is there's two answers here. You get the absolute value of x is equal to 4 when you take the square root like this. Okay? And so x could be plus or minus 4. And you'll see where this is going to come into play with our negative infinities here. Let's motivate it with a problem. Limit as x goes to negative infinity. Let's find a good one here. I like this one. This one will work really well. Let's do the square root x squared plus x plus 1 plus x. Okay. And so let's start with just our normal practice of how we did it when it was positive infinity. We're going to multiply this by the conjugate because we need to force a fraction. Okay. Now I'll multiply this out kind of quick once again, so don't get too lost in the algebra. So I'm going to multiply this, x squared plus x plus 1 minus x squared over all this stuff on the bottom. Okay, and then this cancels here. What are we left with? We're left with this guy here. And so far it's the same as how we would have done it if it was positive infinity. But as you will see, something will change here. So at this point, we're doing our normal strategy. We're going to multiply by 1 over x. This is where things are going to get interesting, okay? The top, no different than what we had before. If I multiply this out, I'm going to get the limit. X goes to negative infinity of 1 plus 1 over x, okay? The bottom will be different in a second, but let me just start with this. Okay, so just some algebra here and multiply this out. And here's where it gets tricky, and I want to focus on this guy here. If I am taking the limit as x goes to negative infinity of 1 over x, this is a negative number. I know you in your mind it's going to approach 0, like you would think this just approaches 0, right? But the issue right now is it's being multiplied by the square root and all this other junk. So we can't jump to conclusions yet. And so just like before, I want this thing in the square root. I want to write 1 over x, a square root of 1 over x squared. There's just one little problem when you do this, is this here, when x is going to negative infinity, this whole thing here should be negative. And the issue is that when I rewrite it in this form here, it magically becomes positive, right? Because if you plug in like negative a million here for x, you square it and then you take the square root, it's now all of a sudden positive. And so these can't really be equal the way it is right now. The only way we can get this 1 over x equal to the square root of 1 over x squared is if you throw a negative in front of this, okay? And so the big rule is that when you have 1 over x to some power n, and you're multiplying it by a square root of some kind, and n is odd, right? N is odd. If it's even, we don't do this. If n is odd, you have to put this negative outside here. So for example, if instead we were multiplying by 1 over x to the third, that would be square root 1 over x to the sixth with a negative out front. And now we don't have to do it for 1 over x squared. Reason being is, remember, x is going to negative infinity. If you square a negative number, it becomes positive. So it's still the case that it's equal to this here, because this right side will yield you a positive. And so that's the big difference here, and you'll see it'll work out really well. If we do our limit now, so x goes to negative infinity of 1 plus 1 over x over negative square root of 1 over x squared times all of our other stuff. We'll be good to go. I'm going to multiply all of this together now, leaving that negative out front, just hanging out. That's going to be negative square root of 1 plus 1 over x plus 1 over x squared minus 1. Okay. Now it's our usual stuff. This approaches 0. This approaches 0. This approaches 0. At this point, we're taking the limit. So x goes to negative infinity of 1 over negative square root of 1 minus 1. So we're going to go. That's 1 over negative 1 minus 1. And you get negative 1 over 2. Just like that. So to reiterate, limits at negative infinity, a little trickier. This property here still holds. Your ones with the fraction here work the same way. The issue is when you have square roots, you have to be careful. If on this step right here, one right here, if you're multiplying by 1 over x to some odd power, when you do this thing here, when you take this 1 over x and put it in a square root, you have to throw a negative sign out in front of it. Reason being is, remember, if you have 1 over x to an odd power and x is going to negative infinity, we know it's a negative number. And so we need to make sure the square root yields a negative number, so we throw that negative out there. Other than that, the problem solving process is the same. I know this could be tricky for people, which is why I made a separate video for negative infinity.